Okay, this question says the vertex of a parabola is 5, 1, and the focus is 2, 1. We want to determine the axis of symmetry, determine the equation of the directrix, determine the equation of the parabola, construct the graph, find a point on a graph, and show that that point is equidistant from the focus and directrix. So let's go ahead and go to Desmos and visualize this. So I will do that. We have the points we are interested in, namely the vertex is 5, 1. And we'll label that as a V for vertex. And the focus is 2, 1. And I will label that with an F for focus. Now, we start at the vertex and the parabola must encompass the focus. So this is a graph that looks like this, or a backwards C graph. So I know the shape of this is going to go this way. That's a y squared equals 4px graph, where p is negative. Except, of course, we're shifting it. The vertex is 5, 1. So y minus h squared equals 4px minus k to translate it. Move it over hk. Shift it to the right h. Shift it up k. So what is my vertex here? My vertex here is 5, 1. So h is 5 and k is 1. So I get y. I think I messed up the h's and the k's here. Let's fix that. Y minus k, x minus h is what I want to say here. That's more typical notation. So y minus k, y minus 1 squared, because that's the shift in the y direction, equals 4p times x minus 5. So that will go through, but I need to figure out what p is. P is the directed distance from the vertex to the focus. We know p is going to be negative here since it's opening to the left. Let's take a look at what p is in our picture. From the vertex to the focus, 1, 2, 3, p is negative 3. So what will that give me? That gives me y minus 1 squared is 4 times negative 3 times x minus 5. Y minus 1 squared equals negative 12 times x minus 5. So let's take a look at that graph. And then we'll talk about axis of symmetry and directrix and such. Y minus 1 squared equals negative 12 times x minus 5. So there's a graph for us. Now, axis of symmetry, and maybe we need to make this like that. The axis of symmetry is this horizontal line. Okay, what is that horizontal line? What does it equal? That's a y value of 1. So the axis of symmetry comes in at y equals 1. That's the mirror cutting it down the middle. Now, how about the directrix? Remember, the vertex is halfway between the focus and the directrix. 1, 2, 3 this way. The directrix would be this line. What is the name of that line? All of those x values are 8. So the directrix should be the line x equals 8. So we see that. So we have our axis of symmetry, y equals 1. We have the equation of our directrix, which is x equals 8. We have the equation of our parabola, which is y minus 1 squared is negative 12x minus 5, and we've constructed the graph. Now, I would like to find points on the graph. P is essentially 3. If I double 3, I get 6. Go up 6 from the focus. 1, 2, 3, 4, 5, 6. That point is 2, 7. 2, 7 is a point on the graph. It's a point on the lattice rectum, as is 1, 2, 3, 4, 5, 6, as is 2 comma negative 5 if you would prefer. But I'm going to stick with 2, 7 is my point on the graph. Okay, so what is the distance from 2, 7 to the focus? 1, 2, 3, 4, 5, 6, twice P. What is my distance from 2, 7 to the directrix? 1, 2, 3, 4, 5, 6, again, twice P. So that's the nice thing about those points, that you just double P from the focus, and then you can find an easy distance. So the distance from 2, 7 to F is 6. The distance from 2, 7 to the directrix is 6. Therefore, we've shown that the point is equidistant from the focus and from the directrix. Maybe draw a little picture of that just so we can visualize it. So x equals 2 from 1 to 7. 1 less than y less than 7. We see that one is 6. And then we could say y equals 7 from 2 to 8. Y equals 7. And say 2 is less than x is less than 8. Make that blue as well. Oops. So you can see these are both 6. Distance from the point to the focus is 6. Distance from the point to the directrix is 6.